Alpha Centauri is not science fiction. It is real. It is just over 4 light-years away, and if humanity ever becomes a true interstellar species, this triple star system may be our very first destination. We've known about Proxima Centauri B for years now, a rocky world maybe about Earth's size, orbiting an angry red dwarf star. It sits right inside the habitable zone, but also inside a storm of radiation and extreme space weather that might make it a living inferno instead of a second home. So, can anything really survive there? And how are scientists seriously planning to send probes there in our lifetimes? In this video, we're going to unpack the latest research, the newest telescope data, and the real roadmap that might take us to Alpha Centauri before the next century. Alpha Centauri is the closest star system to Earth, about 4.37 light-years away. But it's not a single star, it's actually a triple star system: Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. Alpha Centauri A is a bright, sun-like star. Alpha Centauri B is slightly smaller but still similar to our Sun. And Proxima Centauri is a much dimmer red dwarf orbiting the pair at a large distance. Data from NASA's X-ray Observatory and other telescopes show that the environment around Alpha Centauri A and B is actually less harsh than the Sun's in terms of X-ray bombardment for any potential planets. That makes A and B very attractive targets for searching for life-friendly worlds. From 2025, observations with the James Webb Space Telescope have added strong evidence for a possible gas giant-sized planet orbiting Alpha Centauri A. If confirmed, this would make Alpha Centauri one of the most exciting nearby systems in all of astronomy. Now, let's zoom in on Proxima Centauri. This star is much smaller and cooler than the Sun. Because it's so dim, planets must orbit very close to stay warm enough to liquid water. And that's exactly where Proxima Centauri B sits. Studies show that Proxima B is roughly Earth mass or slightly heavier, which means it's likely a rocky planet, not a gas giant. It orbits inside the classical habitable zone and receives about 65% of the sunlight Earth does. Without any atmosphere, its equilibrium temperature is about -39 degrees Celsius. That sounds cold, but with the right atmosphere, it could still be warm enough for water. The problem is, Proxima Centauri is a highly active red dwarf. It constantly erupts with powerful X-ray and ultraviolet flares. Research suggests that Proxima B may be hit by X-ray doses hundreds of times stronger than Earth's. And during big flares, that can jump to tens of thousands of times Earth's levels. If the planet lacks a strong magnetic field and a thick atmosphere, its air could be stripped away over time. So, Proxima B might be a rocky world with a hostile, radiation-baked surface. Because Proxima B is so close to its star, scientists strongly suspect it's tidally locked. That means one side always faces the star in permanent daylight, while the other side is locked into permanent darkness. On the day side, temperatures could be scorching hot. On the night side, they could drop far below freezing. But between these extremes, there may be a narrow band scientists call the Twilight Zone. Recent climate models suggest that if Proxima B has oceans and a thick atmosphere, giant winds and ocean currents could carry heat from the day side to the night side. In that scenario, a thin strip between fire and ice could stay warm enough for liquid water to exist. Some researchers even argue that such a twilight corridor could be a stable place for life, provided organisms can withstand high radiation levels and survive under extreme conditions. In 2024 and 2025, the James Webb Space Telescope began observing the Alpha Centauri system in detail. For Alpha Centauri A, multiple long-exposure observations reveal a strong candidate for a gas giant-sized planet, possibly orbiting at 1 or 2 astronomical units from the star. For Proxima Centauri B, the picture is less clear. There is no confirmed detection of an atmosphere yet, and the current telescope sensitivity is still limited. We're still waiting for deeper observations that can test whether Proxima b has oxygen, water vapor, or other gases. To really answer the question, could life exist on Proxima b, we need either 1. Future giant telescopes that can directly image the planet and hunt for biosignatures, or 2. More advanced models that can simulate many possible atmospheres and compare them to real data. For now, the scientific view is not, yes, aliens live there, but more like, it's possible if the planet is protected enough and conditions are just right. Now, how do we actually get there? Today's spacecraft are far too slow. Even the fastest probe we've ever built, Voyager 1, would take tens of thousands of years to reach Alpha Centauri. In 2016, the Breakthrough Starshot project was announced, aiming to send gram-scale light-sail nanocrafts pushed by a massive ground-based laser array. The goal was to accelerate these tiny probes up to about 20% the speed of light, reaching Alpha Centauri in 20 to 30 years. But by 2025, reporting from major science outlets showed that Breakthrough Starshot is on indefinite hold. Only a fraction of the promised funding has been used, and the project is now more of a technology incubator than an active mission. At the same time, physicists and engineers are still working on laser-driven sail concepts as part of long-term roadmaps, sometimes stretching 30 to 50 years into the future. NASA and other space agencies are also exploring ideas for interstellar probes that could reach 10% the speed of light, which would cut the travel time to Alpha Centauri to 44 years. In 2026, the honest answer is we know how to think about interstellar travel, but we don't yet have the money, the political will, and the fully matured technology to launch such a mission. Alpha Centauri is no longer just a faint dot in the sky. It is a real star system with at least 3 stars, several likely planets, and storms of radiation and flares. It's a testbed for whether life can survive on a world that is tidally locked, constantly bombarded by flares, and forever split between burning days and frozen nights. And it's the first serious target for interstellar exploration, not in some easy, distant future, but in a future where we'll have to push the limits of materials, lasers, and optics just to send a tiny chip across the void. If we ever get there, we won't just be sending a probe, we'll be sending an answer to one of humanity's oldest questions. Are we alone? And are we ready to become a species that truly lives among the stars? If you want more deep dives like this, hitting new research on Alpha Centauri, Proxima b, and future interstellar missions every year, hit subscribe and turn on the notification bell. This star system is just 4.4 light-years away, but in terms of what we know, it's already changing everything.